All right, so for today, I just wanted to go ahead and go over a few problems on the pre-calculus review packet that I had given you. I really want to make these videos a lot more, so that it can help you along the way. I feel that in this class we're going to be using a lot of algebra, so it's very, very important that you're able to simplify algebraic expressions, such as in question number 1. So we're going to go ahead and go over question number 1 first in this video. I'm going to show you 2 alternate ways to be able to simplify this algebraic expression. One way is actually a little bit better than the other, but I think going over the 2 different ways of simplifying this expression is very important. So I want to go over the first way of simplifying this expression. So if you look at this expression, we have this top piece being divided by this bottom piece. So really what you have here is you have a numerator being divided by this denominator. So the idea here is, for this first way, is to focus on the numerator. So what I'm going to go ahead and do is go to a different page. And I'm going to focus on that numerator for right now. So we have the numerator of question number 1, and we're going to simplify this by itself, and we'll go from there. So here, what I want you to know is you have a fraction minus this variable. So you can actually think of this as, if we think about just numbers in general, if you had a fraction and you're subtracting some random number, let's just say 1, recall that when you have a fraction subtracted by a whole number, you want to make sure that you get a common denominator with each of these 2 numbers. And the idea here is that you want to look at this denominator and multiply this number by that common denominator. So if we go back to our expression over here, erase that. If you go back to our expression over here, same idea. We have this fraction minus this variable, and we want to get a common denominator. Here, our common denominator would actually be a. So what we would do in this case is we would get a and multiply this by a over a. So let me write that down. A over a. And if we can continue with this, this is equal to 25 over a minus a times a, which is a squared, all over a. If we continue with this, notice that now these have the same common denominator. So then now you can combine these expressions. Be real careful with this negative here. So this is equal to 25 minus a squared all over our common denominator, which is a. So now that we simplified the numerator of our expression that they gave us, I'm going to rewrite this and go back to our original expression. So this is equal to 25 minus a squared all over a. So that's another way to write this. And then all that is divided by 5 plus a. So if we continue going with this, here is actually one of the most important parts that you have to understand. So here, same idea, we have the numerator being divided by some other term. What I like to think about in this situation is we can rewrite this as saying this whole thing, our numerator, divided by, so I'm going to put the division symbol, our denominator, 5 plus a. And then if we recall our rules on division, whenever we're dividing by another term, the idea here is to change this division symbol to a multiplication. So let me rewrite this. So we're going to change this division symbol to a multiplication. And here's the most important part. This right here will take the reciprocal of that. Okay. So we'll take the reciprocal of this, which is 1 over 5 plus a. And if we continue going, that is equal to 25 minus a squared times 1, which is just 25 minus a squared. And then we have a times this right here. So it'll be a times 5 plus a. And be real careful here. You want to make sure that you put the parentheses around this when you're multiplying by another term, okay? So don't forget these parentheses. And now, at this point, remember, in problem number 1, we started off with this, and now we're at this point. So at this point, you want to ask yourself if there is any way to simplify or factor this expression further. So we kind of have already simplified this expression up to this point, but we also have to consider if we can factor. So factoring is one of the most important parts in algebra. And if you look at this numerator, it's kind of hidden in there, but this is actually what you call a difference of squares. Difference of squares. And please recall that with difference of squares, this is giving us an algebraic way of factoring. So the idea behind difference of squares is if you have a situation, more generally, x squared minus y squared, the most important thing here is that you have that difference sign, that subtraction sign in there. Whenever you have the situation, that's the same thing as saying x plus y times x minus y. So this difference of squares property allows us to factor this expression into this. So if you look back at this numerator, notice that you're able to write this as 5 squared, because 25 equals 5 squared, minus a squared, all over a times 5 plus a. And if we continue going with this, using the difference of squares property, another way to write this is just 5 plus a times 5 minus a, all over a times 5 plus a. And at this point, you want to ask yourself, is there any way that we can maybe cancel out some terms? And in this expression that where we factor the numerator, after we factored this expression in the numerator, notice that you have the 5 plus a in the numerator and in the denominator. So at this point, you can cancel out these factors right here. Okay. And then ultimately what you're left with is 5 minus a all over a. And this right here should be your final answer. So this is one way of approaching this problem of simplifying this algebraic expression. Another alternative way, which is a little bit more efficient, is I'm going to copy the beginning here. Another alternative way is here. So once again, we just went over one way of simplifying this expression. Now I'm going to go over the second way of simplifying this expression. The second way is to look at both the numerator and the denominator. And the idea here is you want to multiply the numerator and the denominator of this fraction by a common denominator. So let me write that down. You want to multiply this expression by a common denominator. Okay. So here, if we look at this, notice that in the numerator we have this fraction. In the denominator here, we have this a. So the idea here is that you're going to look at this denominator, and you're going to multiply this whole thing by this common denominator. So you're going to multiply the numerator and the denominator by this common denominator. So if you write that down, it'll be parentheses, multiply the numerator by a all over a. And then what we would do is we would just multiply across. Okay. So if we do that, that should be equal to 25 over a minus a times a all over 5 plus a times a. And then if you look at the numerator, we can use the distributive property to help us get rid of this denominator. So if we were to do that, we would get 25a all over a minus a times a, which is a squared, all over 5 plus a times a. There's a reason why I didn't distribute this a, and that's just because ultimately what's going to happen here is that this 5 plus a is going to be canceled out, and you'll see that right now. So if you look at the numerator, you have a over a. These a's will cancel out. Ultimately, what you're left with is 25 minus a squared all over 5 plus a times a. And then once again, we have to use the property of the difference of squares to help us factor this numerator. And we said earlier that that should be factored as 5 plus a times 5 minus a all over 5 plus a times a. And then similarly, like we had discussed earlier, you'll notice that the 5 plus a's will cancel out. And you're ultimately left with the same simplified expression that we got using the first method. Okay. So hopefully these steps make sense. I'll be uploading a few more videos covering the next few problems. And like I said, you can use either method here. Either method works. Once again, I think looking at these two different methods is important. And I really hope that this is helpful for you in understanding how to approach question number 1. Thank you.